We're going to cover the exact values of our 6 trig functions on some special angle measures. We're going to start with 45 degrees. Now, I'm going to tell you, I'm going to go through all of these exact values in degrees today, but we won't be working with degrees in calculus. We'll be working exclusively with radians in calculus. And you say, well, why don't you just give it to us in radians? Because I have some students that have not had trigonometry. Since they haven't had trigonometry, they don't even know what an exact value is. So I don't want to overburden those students by teaching exact values and radians all in the same lesson. So we're going to take a day and we're going to do all the exact values working in a mode, a degree mode, that all students should be comfortable in. And then the following day, we're going to convert degrees and exclusively from that point on, work in radians. So for today, we're going to talk about degrees. Here's where your exact values come from. For those of you that have had trig, you might not recognize or realize that those exact values that you worked with in your trig class came from geometry. And so let's go back to geometry and let's talk about special right triangles. We had 45, 45, 90s and we had 30, 60, 90s. We're going to start talking about 45, 45, 90s first. If I have a special right triangle, if I'm in a right triangle, I can talk about trig values, talk about angle measures. So if I'm in a 45, 45, 90, there are some things that I know from geometry about this triangle. I know that the two acute angles have to be the same measure because I have a 45 degree angle, I have a 90 degree angle, and 180 minus 90 minus 45 leaves 45 degrees for the third angle. So I know that those angles are the same measure. That puts me in an isosceles right triangle. And if I have angles that are the same measure, then the lengths of the sides opposite those measures have to be the same measure. That's why I have both of these labeled as x. The length of side AB is equivalent to the length of side BC. I am in a 45, 45, 90 special right triangle. Since that's the case, I remember from geometry, in a 45, 45, 90 triangle, I had a leg, I had another leg that was the same measure, and I had a hypotenuse. And what was true about my hypotenuse is that it was square roots of 2 times the length of a leg. I'm bringing that from geometry. So if I call the length of each leg x, then the length of the hypotenuse has to be the square roots of 2 times x. Remember, multiplication is commutative. I can write this in either direction. It doesn't matter. That's just multiplication. So there's my hypotenuse. So let's talk about the 6 trig ratios for 45 degrees. We'll do it in terms of x. So the sine of 45 degrees, now I have a measure for theta. In this triangle, theta is 45 degrees. I don't care the size of my triangle. If I determine that one of my acute angles is 45 degrees, the sine in that triangle, regardless of whether it's super tiny or as big as a mountain, will always be, remember sine was opposite, there's x, over hypotenuse. That is square roots of 2 times x. Well, let's clean it up algebraically. Now we're down to algebra. I have x over x. That doesn't disappear, by the way. Let's just take a little algebra moment here, shall we? X divided by x has a value of 1. So what we've done now is we said we're dealing with 1 over the square roots of 2 times 1. I kind of dislike the fact that we teach our math students to cancel things because they get the idea that they disappear. They don't disappear. They have a value of 1, and we're multiplying. So the sine of 45 degrees is 1 over root 2. My trig students should recognize that. They won't recognize that exactly because you get taught in lower mathematics that you get taken to math jail if there's a root in the denominator of a fraction. Well, I'm here to tell you there is no math jail. These are equivalent statements. I'm multiplying by a well-chosen 1. I can multiply anything by 1 and I get the same value back. So I have very carefully chosen a 1 that is going to help me get rid of the radical in my denominator. There's the exact value my trig students are going to be used to seeing. All right? Let's talk about cosine of 45 degrees. Remember, cosine, let me get rid of some of this mess. Let's talk about the sine of 45 degrees. We said was root 2 over 2. Let's talk about cosine of 45 degrees. Cosine, remember, if this is my 45-degree angle, was adjacent over hypotenuse. Well, lo and behold, look where we are. We're at 1 over the square roots of 2. We can rationalize the denominator. And there's the cosine function. Tangent of 45 degrees was opposite over adjacent. There's why the tangent of 45 degrees is 1. All right. Let's talk about cofunctions. The cosecant of 45 degrees. Well, that's 2 over the square roots of 2. Let's come back up here and let's remember, before we brought algebra to the party, that the sine of 45 degrees was 1 over the square roots of 2. We know that cosecant is the reciprocal relationship, so we know we're dealing with square roots of 2. We know that secant is identical. Why? Because cosine of 45 degrees is identical to the sine of 45 degrees. And lastly, cotangent of 45 degrees, the reciprocal of 1 is 1 over 1, or just 1. So there are the 6 trigonometric ratios for 45 degrees. Let's see if we were right. Sine of 45 degrees, cosine of 45, tangent of 45. I want to say something, although I still believe I'll have students that do this. I often get answers that look like this. Do you see problems with that? And I mean, I get this a lot right at first until I do a lot of hollering. These functions have independent variables. There are input values, just like y equals the quantity x squared has an input value and a resultant output value. These functions do as well. The input value is the angle measure in every one of these functions. Every one of them are the sine, cosine, or tangent of an angle measure. This is the sine of, I don't know, blue sky, the sine of blank. You can't tell me that the sine of blank is root 2 over 2 because it's only a true statement if blank had an input value of 45 degrees. So be careful and make sure, especially those of you that have not had trig before and these are new functions for you, make sure that you understand that we have input values where the sine or cosine or tangent of an angle measure gives us an output. All right? We have input values, independent variable, and output values. And here are the cofunctions. These are the values, again, we did those correctly for 45 degrees. Now let's go to the plane. Let's take our right triangle with our 45-degree angle measure, and let's put it in the unit circle. Remember, in mathematics, the word unit means 1. Well, this is a unit circle because our radius is always 1 in this unit circle. Now, we figured out before, back over here, that it did not matter what our radius was, what our hypotenuse of our right triangle was. When our acute angle measure was 45 degrees, we got a real number value from that on all 6 trig functions. So now we have a radius of 1. That's our hypotenuse. Here is our opposite side. Here is our adjacent side to our angle measure. Back to where we were on the last video. Now, we said that we knew the sine of 45 degrees was root 2 over 2. We said we knew the cosine of 45 degrees was root 2 over 2. Follow me closely here. Notice that if I go a distance from the point of origin, a distance of root 2 over 2, and I'm calling that x, then my x coordinate to that point is root 2 over 2. If I go a vertical distance here from the point of origin, a distance of root 2 over 2, which I'm calling y, then the y coordinate to that point is root 2 over 2. Again, we're in the plane at a point x, comma, y. Let's go back to the sine of theta equals y over r. I'm going to multiply both sides by r. So this says r times the sine of theta equals y. And I want to write it like that. Doesn't matter what direction I put the equal sign. When r equals 1, then y equals the sine of theta. What does r equal in the unit circle? It equals 1. So here's what I want you to make a connection in your head. As long as you are in the unit circle, it has to be true, because this is generic. I don't have an angle measure. It's for any angle. Even though mine's 45 degrees, it shouldn't matter. As long as I'm in the unit circle and r equals 1, then the coordinates of any point in the plane, here I'm specifically 45 degrees from the horizontal for my angle measure, that means that the x coordinate has to be the cosine of the angle measure. And the y coordinate has to be the sine of the angle measure, as long as I'm in the unit circle. Pretty cool, huh?